Welcome back, geometry students, to another edition of your notes. Today's notes are titled 10-2 Reflections. All right, so make sure you get these into your notes. First off, we go through what a reflection is. You might want to pause this video and copy these sentences down, and then come back through with me and fill in the blanks. So a reflection, also called a flip, is characterized when a transformation that flips over a line of reflection. So there's always a line of reflection that I flip something over, I reflect something over. Next, the image, which is the new, and the pre-image, which is the old. So the image and the pre-image are backwards. They're mirror image of each other. So mirror image. They're mirror image of each other, they're backwards. And lastly then, each point is blank to the line of reflection. Well, if something's backwards, if you think of yourself being in a mirror, and you're looking in a mirror, you are the same distance away from the mirror. So each point is, we call that equidistant. So each point is equidistant to the line of reflection. Equidistant, break it down, equa, meaning equal, and distant, distance. So equal distance, equidistant to the line of reflection. All right, example 1, I gave you a copy of these graphs in class, so we're going to go through determining the line of reflection. If you guys put them in your notes already, or if they're loose, either way will work. So for A, we can see that I have these two triangles, triangle PEN and triangle P', E', N'. And we want to find out where is the line of reflection that they are reflected on. Okay, like we just said, the line of reflection is going to be equal distance between each figure. So I can find that by finding pretty much the midpoint. Where's the halfway point between these two figures? I can do that by just looking at one coordinate. Let's take n, and how far away is n from n prime? So count that. 1, 2, 3, 4, 5, 6. 6 units away. So if the line of reflection is equal distance, the line will be 3 units away, which is half of that. So 1, 2, 3, right on this line, is going to be the line of reflection. Okay? Another way to find that is, since these images are flipped on top of each other, I can simply fold my paper, or fold my graph, or whatever I have, to where the image is right on top of each other. It might be kind of hard to see, it is on mine. But make a little crease there, and when you unfold it then, that's going to be on your line of reflection. Same place there. Okay, this is the line y equals 1. And why is that? Well, because it crosses the y-axis at 1, and every coordinate on that line has a value of 1. All right, example B for determining the line of reflection. We can see here that the line of reflection is not going to be a horizontal line or a vertical line. It's kind of a diagonal line going through there. Again, if we fold these pieces of paper, fold them through and then make a crease, and then draw in that line there, there's going to be our line of reflection. Okay, now we need to identify what that line is. My slope is 1. I go up 1 over 1 every single time, and it's a diagonal line there. This is very characteristic of the line y equals x. It's a parent function. You should remember that from algebra and know what that looks like. The other line of reflection that's diagonal is the other direction with a slope of -1. That's going to be y equals -x. Okay? Every line of reflection is either horizontal or vertical, or y equals x, or y equals -x. All right? Next, example 2. I did not give you this graph, so please just sketch out this graph really quick in your notes. We want to graph the image with a reflection across the line x equals 1. So first let's draw in the line x equals 1. It crosses the x-axis at 1, and then that's going to be a vertical line. So here's the line x equals 1. Okay? If I reflect this triangle across that line, it's going to be equal distance on either side of the line. Okay, so let's take each point, and all we have to do is count to the line of reflection, and then count that much farther again on the other side. So if I take D, how far away is D from the line of reflection? Well, I go 1, 2 to the line of reflection, so go 1, 2 more, that's going to be D prime. Next, I have X. All right, how far away is X from the line of reflection? 1, 2, 3, 4, so count 4 more. 1, 2, 3, 4, there is X prime. And lastly, I have T. So how far away is T from the line of reflection? 1, 2, 3, 4, and then 1, 2, 3, 4 again for t, and clearly x was under t was under x, and over here t prime is under x prime. So there's my triangle after I reflect it across x equals 1. All right, lastly, I have example 3. It says find the coordinates of the image. There's A and B here. So A is with a reflection across the y-axis. So I've got coordinates, and I'm going to find k prime. I want to identify here what's a pattern. There's going to be a pattern for each coordinate. It's not necessary to do every single coordinate, but I am going to start with the first coordinate here. If I reflect this coordinate across the y-axis, what happens? The best way to do that is just simply to do that. Take this coordinate, 3, -2, and I'm going to take my trusty pie pencil. I got this free in the mail. Kind of cool. So take pie pencil. Take the coordinate 3, -2, so 1, 2, 3, and then down 1, 2. Make sure you remember how to plot points. All right, reflect that across the y-axis, which is this one here. Again, it's equidistant to the y-axis, so 1, 2, 3. 1, 2, 3 more. There is going to be k prime. So here is k, there's k prime. Now, what is the coordinate for k prime? You go down back 1, 2, 3, so it's -3, and then down 2. So -3, -2. So compare, identify what happened when I reflect across the y-axis. Well, the x coordinate changed, and it just became negative. So we can do the same thing here for b prime. I make the x coordinate negative, so a -4 will become a +4, and the y coordinate stays the same. Okay? So again, when I cross over the y-axis, the x coordinate changes, so that it becomes from negative to positive or positive to negative. So do these last couple by yourself and then replay the video, make sure you got it. J prime will be +5, 1, and then R prime will be -5, -4. Okay, so reflecting across the x-axis means, reflecting across the y-axis, the x value, or the x coordinate, becomes negative. Write that down. It's kind of a pattern every single time. Next, if I reflect something across the line y equals x, what happens to my coordinates j, x, and p? Again, nothing to it but to do it, but we actually have an example of that. So let's go back up here to my example here. If I had the original coordinate, which was here, well, let's take L. Original coordinate was -1, and then -1, 2, 3, 4. So -1, -4 was my original coordinate. And it became over here, now I have -1, 2, 3, 4, and then -1. So how would I go from -1, -4 to -4, -1? Well, they just simply switch places. So when I reflect something across a line y equals x, my coordinates just switch places. So what was the x becomes the y, what was the y becomes the x. So take that for this one. -4, 1 is going to become 1, -4. You do it for the rest of these and see if you can get the rest. So switch places, I get 3, -2, and then p prime becomes 1, -2. All right, so that's what happens with the line y equals x. I can write kind of a general rule here. My xy coordinate becomes yx. Okay, and anytime you reflect something, you can always find it out for yourself, kind of do a test and see what happens. Don't forget your WSQ, and Pi Day is coming up.